Hey everyone, welcome back to a new video. I'm a little unwell, so excuse anything going on with my voice and why I look like just terrible in general. But what we're going to do in this video is we're going to take a look at the grab component. So I've had quite a few people, especially beginners, using the VR template, ask how the grab component in itself works. So the goal in this video is to kind of go through and show you how the VR pawn communicates with the grab component, how the grab component works with different actors, for example the weapons or the cubes and the different grab types, and also we'll take a look at how we can pass variables from the player to the grab component to the actor if we need to go down that route. So it's going to be a general overview and hopefully it gives you an idea of how this works to build your own content. So what this is a component itself can be attached to an actor. So we select one of these guns and I go to the details panel here. You can see that we have a grab component snap. The snap isn't part of this, it's just been renamed. So the type is grab component, which means it's just the grab component that is being attached to the gun and being renamed snap. So you're not looking for a specific grab component snap. And what that's referring to is if you select the grab component, the grab type here is set to snap. You can find this inside of the grab component itself if we open it up. Might look like this, but you can see on here we've got a couple of functions. So in try grab, we have this grab type, and this is essentially telling us what we're doing. So if we attach the grab component to an actor, in this case the cube or the gun, we're using snap, which then disables the primitive component physics, and then attaches it to our gun and tells us that we're held. If it's on snap, we set the relative rotation and the world location so it knows where to go. We'll come back to this in a minute, but for now I just want to show you that that's where this is. If we dock this one, what I want to do is I want to jump over to the player, so in this case the VR pawn, and we're going to take a look at how it works in here. So what we've got is at the basic level, we have an add mapping context, which tells our player that we can use different inputs. That allows us to use these grab left and grab right input actions, and then it reads through the get grab component near motion controller function. So if we double click this, we can open it up, but before we do that, we can see that we're passing in the motion controller left grip. So this is a reference to our motion controller right grip and left grip, which is up here, and these are essentially reading our motion controllers in our project. So when we press play, we get our motion controllers, and then when we press the grab button, we tell our grab component that we're using that left controller. So you can see that we've got two here, so left and right. So in here, what we do is we get the grab component near motion controller, and like I said, this is a function, so we can go inside of it and we can see a whole bunch of information. What's happening is we actually read through, so we get a reference to our motion controller. We're going to ignore this sequence for now, and then we're going to get the world location. So we're getting the world location of our motion controller, we're getting a reference to the location that it is in, and then we're creating a sphere trace, essentially a little bubble around our controller. So if I enable this and we actually jump in, so I'll just do for duration, and we go to VR preview, we can then press it and we can see those spheres. So what these spheres do is if we go up to an object, when we grab, you can see that it overlaps and it turns green. It means that we're colliding with a physics-based object. So we're detecting that by reading this array here, and these actors inside of the scene, so the skeletal mesh is set to physics-based actor. So if it's set to physics actor, it means we're going to be able to detect it. And then what we do is if we actually hit something with physics enabled or with the physics channel, then we can get the hit actor and we can look for a grab component. In here, if the grab component is, or we get the length of the grab component, so that's the number of them on the actor. So if we've got a skeletal mesh with multiple grab components, we check to see if it's greater than 0. If it is, it means we have one, and then we can go through and we can store that locally. So these are arrays, if you're not aware. So it means that we're storing all the grab components on that actor that we've hit into an array, and then we loop through it. This one's doing some math to get the closest grab component on that actor to the hand mesh. And then we also store a variable for that. So we're storing the local nearest component distance. So how far away was it? We don't actually use this, I don't believe. We don't use it much anyway. And then we store the local nearest grab component. With this, what we do is we pass that through to our return node. So the way a sequence works is it fires the first line of code first, and once that's finished, it then moves on to the second. So we essentially run all of this. We get our reference set here on the local nearest grab component, and then it fires then one, which reads that variable and then passes it back out to the player. So if we go back to the event graph, we can see that nearest component is right here, where we check to see if it is valid. If it is valid, it means we've got an actor that has a grab component. If it's not, we don't do anything, we can't grab that. So once it's valid, we get a reference to the nearest grab component. So in this case, on our gun, it's going to be this grab component here. And one of the ways that grab components work is, even though it has the same, we're using the same component on everything, they're essentially different instances of that component. So we can pass different data through to each one and store them in the actor itself, kind of thing. So every time we add one, we create a new location, and then that's got functions inside of it. I hope that makes sense. So we're getting the grab component we're hitting, and we're telling it that we're going to try and grab. So inside of this, what we can do is we can actually double click this one, and it'll take us to the grab component. This try grab function doesn't exist inside of our player. It's solely inside of the grab component itself. So if I double click, you can see that we've got these functions try grab, and then we've got a whole bunch of variables, and this is where it calls through. So it says try grab, we're going to get the motion controller, and we're passing that through. And then we have another sequence. The sequence fires and goes to switch on grab type. So this is where it's reading that switch variable. So here, if it's snap, free, or none, custom, I'll show you how we can add some more in a minute. And then it fires that line of code related to that specific action. So in this case, the ones on the right, or the cubes I believe, are set to free. So what that does is it just takes the primitive. So in this case, it's the static mesh or the skeletal mesh. We can open this function up and we take a look inside. So you can see here, we're getting the attached parent. We're casting to that component that is on that parent, and then we're setting the simulate physics option to false. We're turning physics off on the actor we're grabbing. What that does is it then feeds through to the attached parent. So the actor we're grabbing has no physics on at this point, and then we're attaching it to the motion controller hand. So we can see here that the motion controller gets fed through to attach parent to motion controller, where we get the parent of the component. So in this case, if we take the gun, we have the grab component, which is a child of the skeletal mesh, and that is a child of the class pistol. So it's the parent class, and that's going to attach it to our gun. So it's basically taking the gun, attaching it to the motion controller, so it sticks it there, like just literally attaches it to the controller, which is in our player. And if it's true, it just goes straight through. If it's false, it says we can't attach the parent to the parent, or we can't attach the gun or the box to the motion controller because we haven't really got one. So it's rare that this won't fire, to be honest. So I would kind of need to ignore that. It's there as help if something goes wrong, but in most cases it'll be fine. So once we've attached it to our hand, we get this set up here, which is on free. So if we went up to the cube, you'd see that it's kind of floating around. It's not exactly on the hand, even though we've attached it there. This is where the snap option comes in play. We then set the rotation. But in the meantime, we tell the grab component that we are holding something. This grab component is held, and then we keep a reference to that. So if we go to the snap, for example, we then get the parent, which is the gun, and we set its rotation, or its relative rotation, and its world location to match our parent. So we break this down a little bit more. So we have our rotation, what this is doing is it's getting the relative rotation of our grab component. So that is not this value, not this rotation here. It is the grab component rotation here. So it uses this 80-90 to then set the relative rotation of the gun to match. So that's what changes the rotation to match our grab component. And then we have the world location. So this one does a bunch of stuff. Don't really need to worry about it, in all honesty. I've never actually touched it. It just works. But what we do is we get the attached parent. So in this case, our gun. We get the world location. And then we get the location of the grab component itself. So self here is referencing the grab component. And then we subtract them to basically move them into each other. We invert it. And then we add the motion controller world location to that. So it positions it where we need to go. So it won't be offset. It'll go directly to the motion controller itself. And that's pretty much it for setting the world location. Once that's done, it does the same thing as the sequence. So it goes down in order. So we run this whole section up here first, depending what our grab type is. And then we run then one, which we check to see if it is held. If it is held, which we've got here, and you see we've got it on all of them. So if it is held, we go true, and we get a motion controller, and we set the motion controller reference. So that is stored in here, so motion controller reference. And then we call the onGrabbed event dispatcher. So event dispatchers, if you don't know, are a way of communicating between blueprints. We can essentially tell a blueprint, in this case a gun, that we have grabbed this component, and we can make the gun do something. And after that, we play a vibration through the controller, a haptic effect, while also saying we are held. So if we follow this through, if we kind of loop back, we pressed our grab button, we've got the grab component closest to the motion controller, and we've checked to see if it is valid. If it is valid, we get the motion controller position, or we get a motion controller reference fired to try grab, which then goes through and runs this first line of code, attaching it to our hand, which is done in this section here. And if you're using snap, it also changes the rotation and location to match. Once that's done, we then go down to the bottom sequence, where we check to see if it is held. And if it is, we set a reference to the motion controller, and we call onGrabbed, and then play a vibration. So call onGrabbed is this dispatcher which we've just covered, and that is now accessible inside of our grabbed actor. So in the gun, let's take a look. Browse to asset, reload. We can see here we have these two events, onGrabbed and onDropped. We'll come to onDropped in a moment. But the onGrabbed, you can see the event dispatcher shows up here behind my head. If I move, you can kind of unlock. That's the wrong way. You can use the onGrabbed function to tell it that the grab component has happened. So in this case, when we grab an actor, we say the actor has been grabbed, we're telling it, and then we enable input. We get the player controller, we tell the actor that it has the ability to have inputs enabled, and then from the grab component, we get the held hand. So we haven't looked at where the held hand function is. That is also inside of the grab component, and it exists as its own function. And we can see that we've got the get held by hand function here. This function is different to ordinary ones, as it is actually set to be a pure function, which means when we call it, for example in try grab, we have a reference to it here. See, there's no execute pin for setting the information. So a pure function means that once this blueprint needs it, so it calls the hand, it actually fires it for us. So it plays here, it gets a reference to our motion controller, determines whether it's the left or right grip, and depending on what we're using, it gives us a return value. So this here is actually a reference to our motion controller controller hand enum. You don't really need to touch this, but that's how this works. We go back to the pistol. We're essentially getting the grab component. we get the held hand function, and once we get that, it runs for us, getting the motion controller returning whether it's the right or left hand. If it is the right or left hand, we select the input mapping context, so basically our inputs for this blueprint that it can use. This is done through the enhanced input system, and then we add that mapping context to our actor, essentially. So once we've added these inputs to our actor, it means we can read them where we need to. So in this case, we then read the actors or the inputs. So we say when grip is started, or in this case it's trigger actually. When trigger is started, then we get the grab component, so a reference to it here, just dragged in, and we look to see what hand is holding it. So get held hand. If it is equal to left, then it means we're pulling the left trigger. If it is equal to right, it means we're pulling the right trigger. And then we fire the same line of code for both, where we get the muzzle location, spawn a projectile, and then we play the haptic effect. So that is it for grabbing and enabling inputs. We go from the player to the grab component, where we try grabbing. If we're successful, we then go to the actor, where the actor listens to that grab component to see if we can use the inputs. If it is activating the on grab, then we can use those inputs, and then we trigger them here. What we also have is on dropped, which is the second step in the process. This requires us to go back to the VR pawn, which we have here. So same on both of them. What we do is we say on our inputs, when the grip button is released, so it's completed its event, we're going to check to see if the held component left is valid. And we're storing that variable up here. So on try grab, if it's true, we get a reference to the grab component which is held. So now if it is valid, if you don't know how to get this node, what you can do is you can actually get a held component. Let's find a variable for that. So a held component left, you can do get, and then you can right click and we can do convert to valid get. So that gives us a reference, and what that allows us to do is it means we don't have to do something like variable is valid. It does it all for us in one node, which is really nice. So if the held component is valid, it means we have a reference to the hand, to the grab component that we're holding in that hand, and then we can call the try release function. This try release function again exists inside of the grab component. So if we go back to it, we can then see that we've got try release up here, and it's available in the functions menu on the left. So try release, it's very similar to try grab. We're getting the event through to a sequence, and we run the first line of code. If the grab type is a specific one, in this case free and snap, primarily they all go through this unless it's custom, then we simulate on drop. So this simulate on drop is another reference which we can then get and set, and you can see that it is set inside set should simulate on drop, which if we look at this is used in our grab components event graph. So on begin play, we set should simulate on drop to true. So we go through, we set this to true, and that means it's going to fall down. If we set this to false, so if I do this on here, we'll say it is false, and then we press play. That's not what was meant to happen. That's why it happened. So the actors themselves are physics actors, so they have the physics enabled. So we just use the simulate on drop as a reference. Say we can do that. So we go back. So we go simulate on drop. It's set inside of this function here as well. So event graph on begin play, we set simulate on drop to true, and that reads into try release. So it sets it here to true, which means it sets primitive component physics to simulate. So it's going to make it fall down. We could actually change this from the actor itself. So I think if we go to here and then we do event begin play, we could get the grab component, set simulate on drop. So if we do simulate on drop to false, what we could do is we can jump in I don't think it's been set anywhere else. This is one of the things that I very rarely touch because we always want something to fall down after release. And then what we can do is we can go up, and then if we release, you can see that simulate on drop is set to false. So now it doesn't fall down. It's going to stay where it is because on release, we're not telling it to simulate that on drop. So if you want something to be released and then just kind of hover in front of you, that's one way to do it. Just call it into the actor. But in this case, we're going to go back to the grab component, try release, and then we can go through. So simulate on dropped, if it's false, essentially just detaches it from the player's hand. So it'll make it just stop. And then set primitive component physics. That is exactly what it says. If simulate on drop is true, we're going to simulate physics and allow it to fall to the ground. Then we tell is held to false. So we're saying we're not holding anything anymore. We've detached it. We're then going to go through to the next sequence line. Check to see if then 1 is equal to held. If it is, then we're going to be released. And then if not, we're going to call on dropped and then tell it that it's released. We use that inside of the character. So we go back to our character, we do released here. So that's passed outwards. Same as is held in the grab component try grab. So try grab is held here and then is held. This goes back to the player and then outputs. It comes back out. I'm so used to just blitzing my way through this that I completely forget about some stuff. So now that we're saying we're not holding an object, it is not held, we're going to call the onDropped event dispatcher, which we've got here, and then we're going to say is released. So we do it a step at a time. We do the onDropped. That is listened to in our player. So we have it here, onDropped, which again is from the grab component snap, onDropped event. So if I try and lean out the way, come on the video, we're going to do it, onDropped, there we go. You can see that we can actually use this as a reference. And we say the object's been dropped, we're going to disable input inside of this actor because we don't need to pull the trigger anymore. So that goes through. It gets the same thing from the grab component, it gets the held hand. If it equals right, it'll get the right input mapping context. If it's left, it'll get the left. And then we just remove that mapping context. So with that done, it basically happens at the same time that our player calls this branch. So it is released. If it is, clear the held component left variable. So that is really it for the logic flow. I know it's taken a little while to get this explained, but there's a lot in it, and it makes sense that you know the route that it goes through. So we've got our player has an input mapping context. So when we grab left, we get the grab component closest to our left motion controller in this case. If it is valid, we try to grab that grab component, and then we give it a reference to the motion controller as well, where we say is the held component if it is held. Grab component, try grab, it goes all the way through and sets this up here. I did mention that if you want to do custom versions, what you could do is you can modify this grab type enum. So if we go into here, we can see that we've got this enumeration. We can open this up and do grab type. We could do, let's say, static interactable, which is one thing I do in the GDXR template. If you haven't seen that, check the link down below. Reference to it in the marketplace. Static interactable. We can hit save, and now if we go back to our grab component, we can see that it's added in here. Now, if you add a custom channel, like you want to do custom functionality, you will need to make sure that it does the is held and has it in there. So what we do is we can do static interactable is held, and then actually let's just duplicate this down. And in this case, we could say set primitive component physics to disabled. So if we grab it, there is no physics. And then if we release it, we can make it go to the same place. So essentially it's going to be locked in the world, but we can still grab it. If I've done this right. Which I don't think I've done. But if we select the cube now, we can see that on the grab component, we now have the option for static interactable. So that's going to fire that line of code. So what this will do is, now that I've thought about it, when we grab it, it's going to set it to no physics. So let's take the gun, and I want to say with these ones I can shoot them, but as soon as I grab this one, nothing's happened, but we have grabbed it. And now if I try and shoot it, we're not going to be able to go through it because we've set the physics to be disabled. So I'm doing this because we're still using the physics actor collision preset, but you could have this for things like displayed on the wall. So I think it'll just fall straight down. If I do simulate, let's just double check. Yeah, so it just falls to the ground. So let's take this one, or the cube, and we say event begin play, get the grab component, and we disable grab type. If we do grab type, get grab type equals static interactable. We can say true. You'd probably do this a little bit differently. Then we can say static mesh simulate physics to false. So now when we press play, hopefully that cube stays exactly where it is on the wall. But what we can also do now is get a reference to the grab component. And we say on grabbed, we do print string, and then we can actually jump in and test it out. So we get in the headset, the cube is now on the wall. We can go up to it, and now if we grab it, we should be able to see that print string playing for us. So now I've got a static interactable grabbable object on the wall, and I could tell the code to do something in there. So we could have static mesh get, we could get the grab component, get the motion controller reference, so this is the hand that we're grabbing with, set world rotation, we do a find look at rotation, get the world location of the motion controller, which is going to be our target. We want the cube to look at this, so we'll get the static mesh, get world location, and then we feed that into here. So when we grab it, it's going to update the position to match our rotation. We could do this on event tick to make it update over time. But if we take a look at this now, what we can do is we can go over, we can grab it, and you can see that where we're grabbing, it's going to rotate around to make that face look at the controller. So you can do a whole bunch of stuff with it, and you can make it work. So we can say event tick, plug that into there, and we can do a branch, promote to variable. I'm not going to name this, we're just going to do this real rough. Set to true. So if it's true, we update the world rotation, and if it is false from the grab component, we're going to say on dropped, which means we've released our hand. We're going to say set to off. So we no longer grab. And I figured out the reason for it is that the cube, the grabbable small cube in class defaults, actually has event tick disabled. So this wasn't firing at all. So if I press compile now, we did have to change that boolean anyway. We can jump in, we can go over to it. Now when we grab it, we can actually make that face our hand and then rotate around. We got some gimbal lock, but that's the thing. And then when we release, it did not change back. Let's see why we're stopped. I don't think you guys will mind if we just keep it doing. So on dropped, this is actually really important. So I created a new channel in the grab component for custom here. So static interactable, which goes down and then is held. I didn't set up the try release. So in try release, we go through it. You can see that we have static interactable. We don't want to do simulate on drop. We don't need to do any of this. But what we can do is we could do detach from component. So we get the actor and we detach it from the hand. So go through there and then set is held off. We don't want to do the physics for simulate on drop because it's not going to fall down. But now, hopefully, when I release, you can see that it actually stays where it is. So this is basically how the grab component works. There's a lot to it, but it's actually rather simple once you start playing around with it and you can kind of figure out how it works and the flow of logic. But I think for now, that might actually be it. I don't think I need to go through anything else with the grab component. Sometimes the rotation, especially if you're doing the snap, can make a difference. So you can see here that the grab component is rotated 80 and 90. So on this actor, if I set it back to 0, 0, 0, when I grab this gun, what's going to happen is it will use a different rotation because it's using the grab component. So you can see that's actually on the wrong rotation. So double check that the grab component is oriented correctly. This is probably the most annoying thing about the grab component, is understanding which way around that is in. But what you could do is, if you need help figuring out which way the grab component is rotating, you get the grab component, add a skeletal mesh, add skeletal mesh, and then add in the hand. So we search for hand in here, or just scroll down. It's just left. So right, you can see here which angle it's on. So we can then rotate the grab component. And you can see that it updates back to 80, 90 roughly. And you could also move this around. And depending on the location of the grab component, it's going to change where it's held. So put that like so. And then you can kind of delete that skeletal mesh hand. So save all, play. And then we should, hopefully, even though I didn't reset the component. Yes, it's still being overridden. I can reset that back to what its default is. And then if we jump in, we can actually go through and grab it. So it's still rotated. I might have to play around with that a little bit more. It might just be because I've changed the rotation and then I reset it in the viewport. But just keep an eye on the grab component's rotation inside of the actor as well when you're doing the snap functionality specifically. But other than that, I think that is everything you need to know about the grab component. Super easy to work with. It actually makes a lot of sense once you've got the hang of it. Yeah, that's pretty much it. I will stop bothering you. If you like these videos and you want to support the channel, we do have a Patreon, which has a bunch of exclusive content on there. Right now, it's all mixed reality stuff. So if you want to check that out, make sure to do so. There'll be a link in the description. We also have a Discord, which is pretty damn active right now. So if you need any help with this, make sure to head over there and ask any questions you've got. And until next time, stay safe and I'll see you then. Bye.